A close-up eye, faceted like black glass, twitches in the mist. A low, wet rumble unfolds hawk-sized wings. This is not a dinosaur. This is not a bird. This is the world before the world we know. 300 million years ago, our planet wore a different face. No grass, no flowers, no song of birds. Only the slow breathing of forests taller than cathedrals. And endless drips from ferns the size of houses. This is the Carboniferous, a lost epoch, a world that no longer exists. Picture a continent stitched from swamps. Warm rain falls without pause. Rivers wander through peat as thick as memory. The horizon dissolves into humid twilight. Amber and moss green paint the sun, filtered through spores. Every breath of that air would feel electric. Because the air itself is different. Modern science reveals a startling fact. Nearly 35% oxygen back then. Today, it is only 21. That difference is not a footnote. It is the engine of an entire kingdom.
Fires burned hotter, storms rolled larger, and the smallest creatures of Earth were about to grow into something monstrous.
There are no dinosaurs yet. No mammals, no true reptiles ruling the land. Only hunched amphibians, sleek and cautious. They cling to the water's edge. The forests belong to something older, armored, with more legs than teeth. The arthropods have inherited the earth. Insects, millipedes, scorpions, creatures of chitin and instinct multiplying in shadow. In every crevice of bark, in every pool of dark water, they multiply. They evolve. They rise. And under this rich, oxygen-heavy sky, they do something no insect has ever done before or since. They grow. They grow into giants. Before scales ruled Earth, chitin did, and something with 2-foot wings took flight. A shape drifts between the crowns. Not bird, not bat. Neither exists yet, nor for 100 million years. This is Meganeura, the largest flying insect that ever lived. A dragonfly the size of a hawk. Its wingspan reaches 70 centimeters, body longer than a human forearm. 4 wings beat in a low, audible hum. Compound eyes like walnuts gather amber sunset light. Meganeura is not delicate, she is an ancient predator. It hunts from above, watching the swamp with the cold patience of a hawk over unseen prey. When an amphibian climbs a log, when an insect lifts from a leaf, Meganeura folds her wings and dives. She seizes prey with spiked legs shaped into a formed basket, then feeds on the wing, unharried, sovereign. The first fossils surfaced in 1880 within the coal seams of Commentry, a small French mining town. Miners lifted a slab of black stone into daylight and saw a wing print longer than their own hand. For decades, scientists refused to believe. No living insect could grow so large. No lung could sustain it. The secret? Meganeura has no lungs. No insect does. Insects breathe through tracheae, tubes carrying oxygen straight into tissue. In today's air, those tubes cap insect size, grow too large, and oxygen never reaches the body's core. But in Carboniferous air, thick with oxygen, that ceiling lifts. Tubes carry more, bodies grow larger. And they did. Meganeura is not an accident. It is the shape this atmosphere permits, a creature written by chemistry itself. On the ground, something longer than a human crawled through the mist, slow and deliberate. Its name, Arthropleura. A millipede technically, yet no word in modern language prepares you for the truth of what it truly is. 2.5 meters from head to tail, wider than a dinner plate, armored in dark chitin plates. 30 pairs of legs move in slow, hypnotic waves, like the rippling folds of a heavy velvet curtain. Arthropleura is not a predator. It does not need to be. Nothing on the forest floor can harm it. It eats decaying wood, ferns, and the corpses of smaller creatures. It leaves furrows across the mossy floor.
Those furrows fossilize into stone highways, long ancient trails scientists still trace across coal forest layers today. When it walks, the sound is unmistakable. A dry rhythmic scrape of chitin, a whisper of armor. Imagine standing in that forest at dusk. Mist curls around your ankles. Ferns rustle. That sound draws closer. It does not know what you are. It does not care. But Arthropleura shares the ground with something worse. Pulmonoscorpius, a scorpion nearly a meter long. Its tail, thicker than your wrist, tipped with a venom needle. It hunts by heat and vibration, ambushing amphibians that slip out of dark water into the humid night. And around them swarm the smaller monsters, cockroaches the size of house cats, mayflies with half-meter wingspans. Silverfish scuttle in the leaf litter, larger than any modern rat. Every leaf conceals a hidden jaw here. Every log hides a stinger. The Carboniferous forest floor is a gauntlet no vertebrate had yet mastered. This is the ground beneath giant dragonflies. The coal forest pantry, where every predator hides in chitin. But the strangest monsters of this age were not on land. They swam through brackish deltas and river mouths. In the shallow lagoons ringing the supercontinent lived a lineage of hunters older than the forests themselves, the Eurypterids, sea scorpions. Creatures so alien that the first paleontologists to find them called them forgeries. The largest of them, Jaekelopterus, reached 2.5 meters, a body longer than a modern crocodile. Segmented like a lobster, streamlined like a shark, tipped with 2 crushing claws lined with serrated teeth. It swept through brackish deltas with the calm authority of a warship. Jaekelopterus was not a modern scorpion. It had no venomous tail. It did not need one. Its claws could pierce the shell of a trilobite. Its jaws, arranged in a ring beneath its head, could grind flesh into paste, ancient teeth turning steadily. It hunted the early sharks, sharing its waters, the primitive fish darting through the reeds, even its own kind. Recent computed tomography scans of its fossil claws have revealed something extraordinary about this vanished apex hunter. The jaw mechanics of Jaekelopterus generated forces comparable to a modern alligator, not a slow scavenger at all. This was a fast, calculating predator. A tactician of the shallows, patient and precise beneath mirrored water. It hunted by ambush. It rested in the silt, its eyes barely breaking the surface, and waited silently. When a shadow crossed above, it exploded upward in a single stroke, a cloud of mud, a shape twisting. The water went still again. In the ancient shallows, Jaekelopterus vanished into silt, waiting for the next shadow. The sea scorpions ruled the coastlines for tens of millions of years, watching four-legged animals crawl from the shallows. They shared their lagoons with hungry sharks and outlived them across generations. In some estuaries, they were apex predators. No teeth, no lungs, only patience, armor, and time. Now imagine these hunters meeting on one Carboniferous shoreline. A single day at the edge of a vast Carboniferous lagoon, the sun climbs slow through drifting golden mist. A juvenile amphibian, the size of a small dog, drags itself onto a flat rock to warm its skin. It does not know it is being watched from above, where a silent shadow passes and circles back. Meganeura bangs against the gold-lit sky, adjusts, and folds its wings. The dive is silent. The impact is not. The amphibian is lifted, struggling helplessly, and carried into the towering canopy to be devoured limb by limb. Deeper in the forest, Arthropleura pushes slowly through a curtain of ferns. Its long body catches low light. A Pulmonoscorpius resting in a burrow beneath a fallen log senses the heavy vibration approaching through the soil. The scorpion raises its venomous tail, tests the humid air, and slowly retreats deeper into its shadowed hole. Even the venom-tipped hunter yields ground to 2.5 meters of heavily armored ancient millipede here. In this ancient forest, size decides everything. At the water's edge, another quiet drama begins to unfold.
a small tetrapod, one of our own very distant ancestors, wades into the mirrored shallows to drink cautiously. The surface is glass. Then the glass breaks. A claw the length of a human arm rises suddenly, it closes fast, and the tetrapod is gone. Ripples spread. Jaekelopterus sinks back into the silt with its meal. 3 predators, 3 kingdoms, sky, land, and water.
And every one of them is a monstrous arthropod. No fur, no feathers, no warm blood. Only chitin, hunger, and the strange gift of oxygen-rich sky. For millions of years, this balance holds. The giants inherit the world. Then the oxygen began to fall. Around 305 million years ago, the great coal forests entered a crisis of collapse. Geologists call it the Carboniferous rainforest collapse. The climate shifted. The endless rains grew erratic and sparse. The vast wetlands feeding the swamp forests began to dry. The forests fragmented into islands of green. Those islands shrank between deserts of red clay. The giant lycopsids could not survive without standing water. They died in waves. Their bodies no longer decayed into the peat that had sequestered so much carbon. With the forests gone, the atmospheric chemistry began to unravel. Oxygen levels fell steadily across the world. From 35%, oxygen slid toward 23%, slowly over hundreds of thousands of long, quiet, unhurried years. For creatures whose bodies depended on that rich air, it was a death sentence written in the sky. Meganeura's trachea could no longer feed its enormous body. Its wings faltered, its clutches thinned each season. Generation by generation, the great flying giants shrank. Then they disappeared entirely from the darkening prehistoric sky. Arthropleura, once undisputed master of the forest floor, found the peat drying beneath its many armored feet. Its habitat fractured, its offspring struggled. The largest millipede that ever walked the earth was gone forever. Pulmonoscorpius vanished from the fossil record. The Eurypterids clung to their coastlines, but the world was tightening around them. Reptiles, small and quick, were spreading inland everywhere. The old rules were breaking. Then came the final blow. At the end of the Permian, 252 million years ago, the greatest extinction event struck Earth. Volcanic fires in what is now Siberia poured molten lava across an area larger than all of Western Europe. The oceans went acidic, the atmosphere darkened. More than 90% of marine species disappeared forever from Earth. The Eurypterids, last of the sea scorpion dynasties, sank into the fossil record for good. The age ended. The age of monstrous insects was finally over. The coal forests were now literally coal, pressed beneath stone. The giant dragonflies became imprints in slate. Armored millipedes were ghosts in mudstone. A kingdom of chitin erased. Yet their shadows still shape today's insects. Modern science, tracing that erasure, uncovered a simple and beautiful law. The size of an insect is capped by the oxygen it breathes. This has been tested in laboratories. Beetles raised in oxygen-enriched chambers grow measurably larger within a single generation. The tracheal system is remarkably ingenious. So ingenious in its simplicity, it is also a hard ceiling. Insects can only grow as their air permits. That is why the dragonfly outside your window is small. It is not a lesser creature at all. It is a creature of a leaner sky. If our atmosphere ever climbed back toward 35% oxygen, the dragonflies would rise with it. Given enough time, Meganeura could return to shadow our skies once more. In 2024, researchers announced a rare and stunning discovery. Arthropleura's head, unknown to science for over a century. In a French quarry, 2 head fossils were recovered, revealing the face of the largest arthropod that ever lived. 2 pairs of eyes, short antennae, mouth parts adapted for grinding plants. The giant, at last, looking back at us. These fossils tell us how living bodies respond to atmospheres. Climate is not decoration, climate is architecture itself.
When the chemistry of the sky changes, the shapes of living things change with it, slowly, across geological time. What our century does to the atmosphere will decide the size and shape of the creatures who inherit it. The dragonflies at our lakes are miniature echoes of Meganeura, glinting over water on fragile inherited wings. The horseshoe crabs on our beaches are the last cousins of the Eurypterids, sea giants worn down by time. Millipedes beneath your garden stones carry the same blueprint that once produced Arthropleura. Giants gone, design endures. One era ended, so another could awaken.
The curtain falls on the coal forests, peat hardens into stone, oxygen settles. Across drying continents, a red silence spreads. This is the dawn of the Triassic, a world reset. In the cracked earth of these deserts, something small begins to stir. A creature the size of a cat, long-legged, sharp-toothed, watching the sky with slitted eyes. Not an insect, not an amphibian. It is an archosaur, a ruling reptile, the ancestor of everything that will one day fill this reborn world with thunderous roars. The insects retreat. They shrink back into the sizes we recognize today. The reptiles rise. Scales replace chitin, bone replaces armor. Warm blood begins its long experiment. And somewhere in the red dust of the early Triassic, the first true dinosaur takes its first step. It will change the planet for 180 million years. It will produce the largest land animals of all time. It will produce the terror of the Cretaceous. And it will produce a legacy that ends, eventually, in the birds that sing outside your window today.
But that story belongs to another episode. This one closes here, on the last shadow of a giant dragonfly disappearing into a fossilized dusk. A kingdom of chitin sealed in stone. A world that no longer exists, whispered forward into ours through the tiny, patient insects that survived. The age of scales is about to begin. Subscribe to continue the journey through a world that no longer exists. Ring the bell for the next chapter. In the next episode, we step into the red dawn of the Triassic to meet the first true dinosaurs. The journey through lost worlds continues. Follow us onward